Hey guys, so this is the first time for most of you probably that you've had a class delivered in this format. Maybe, I don't know. We're going to try it out and see how it works. I had some pretty good success with it last semester, and I've been working on the schedule over the weekend, and I think we can actually make this work out really well for us in that we're only going to cover half of each section of notes per night. That way, you guys don't have really long videos to watch. You're not inundated with a lot of time outside of school for this class. And then when we meet in class tomorrow, then you will be able to work with one another on the homework problems, at least the ones that you can complete with the first half of the notes, and then we can do the same process the next day. Um, with what we're getting ready to start right now, though, this should pretty much be a review for you guys. Shouldn't be anything too mind bending and challenging for you, but some of you may have forgotten it because maybe you haven't had a math class in a couple of semesters. So you can see from the title we're looking at the distance and midpoint formulas. These are two important formulas that we're going to build on and use extensively for the first part of this class. I'm not going to go through and read everything about rectangular coordinates with you guys. You guys understand what the coordinate plane is. Right here on the left, you have just a plain coordinate plane. It has an x and y axis. X is the horizontal axis, y is the vertical axis. And then in the middle, there is an example of ordered pairs. Remember, it's kind of like an address, a point in the coordinate plane. You have the x coordinate first, followed by the y coordinate. So first we move horizontally, then we can move vertically and label these ordered pairs. And then we have the quadrants named in the on the right-hand picture. So you have quadrant 1, 2, 3, and 4, moving counterclockwise around the coordinate plane. And I've also indicated the signs for the x and y values in each one of those quadrants. The first thing we want to do is we're actually going to extrapolate the distance formula by applying the Pythagorean theorem, because that's exactly where the distance formula originates, is the Pythagorean theorem. And we're going to find the distance between 2 points. We have the point 1, 3, so we move horizontally 1 unit and up 3, and we have the point 1, 3. And then we have the 0.56, so 2, 3, 4, 5, and we go up 6 units. And we want to find the distance between these 2 points. Now, we're looking at this line segment right here. We want to find how long is that line segment. What we have from our picture are these 2 line segments that are not necessarily readily visible. We do draw them in and we can see what they are, and we can label the distance or the length of each one of these segments. So this segment across the bottom, the horizontal segment, is 4 units long, and the vertical segment is 3 units long. Now, if you remember anything about any special right triangles, we already know that the distance from between our 2 points rather is going to be 5, because this is a 3, 4, 5 right triangle. But let's go ahead and figure that out using the Pythagorean theorem. So the Pythagorean theorem tells us that we have c squared, that's our hypotenuse, is equal to the leg squared plus leg squared. So our 2 legs are 3 units and 4 units respectively. So we have c squared is equal to 3 squared plus 4 squared and we get c squared is equal to 25. Take the square root to find the value for c. The square root of 25 is 5. So we've come up with the distance between the 2 points as 5 units. And then here you can see below that we do have the precise definition of the distance formula. The distance between 2 points is going to be given by the difference in their x values, and then you square that quantity, plus the difference in their y values, you square that quantity, take the sum of those 2 quantities, and then the square root, and you come up with the distance between 2 points. This is a proof of the distance formula. You're welcome to study over that. It's not going to be something that you're going to be required to memorize for this course, but it is helpful to understand how these things work and why they work. And the last example, like I said, we're just going to do half the notes. So this is the last example. It's a quick video. We want to find the distance between the points -3, 5, and 3, 2. So this time we're using the distance formula exclusively. We're not going to plot the points and compute the distance using a triangle. So when we look at the distance formula, again, it's d is equal to the square root of the difference in the x values plus the difference in the y values, quantity squared, and we just substitute in what we know. So we have 3 minus -3 plus 2 minus 5. And 3 minus -3 is the same as 3 plus 3, so we end up with 6 squared. And then 2 minus 5 is -3. -3 squared is +9. Sorry, I'm just going to do it this way, not jump ahead. And then when I square 6, we get 36. Like I said a second ago, -3 squared is 9. So we get the square root of 45. Now the square root of 45 is not a perfect square, but we can simplify it. The square root of 45 can be written as the square root of 9 times 5. We can break that apart, and we get 3 radical 5. Now we can break apart multiplication and division in radicals. We cannot do the same thing with addition and subtraction. So just a little side note here, the square root of 9 plus 5, for example, is not the same as the square root of 9 plus the square root of 5. We cannot do that with addition, nor can we do it with subtraction. But with multiplication and division, we can do those steps to simplify radicals. The next video will cover the remaining 2 examples. You're free to go ahead and work through the homework problems if you want to, or if you just want to wait till tomorrow, we can work on them together. Remember, I'm going to be splitting time between you guys and the calculus class, so that's our first video. I hope this is going to work out well for you guys. I'm sorry about the dog barking in the background. I don't know if you can hear it or not. She's a little nuts. So everybody have a great evening, and I will see you in the morning.